left, but we're just going to start on that. 26 itself is like a half-hour lecture at the most. I've just taken certain things out of that chapter, so it's not that long. So even with the review itself, as far as just getting to the end of the material, less than an hour, really of sort of lecture to do it, even with half review. And then people are free to do whatever they want. Again, I recommend that I put the answers to the extra questions, but we're here to talk about the extra questions. The multiple choice I put on just this last year, they're actually multiple choice questions that I've used on these tests. Some of them might be on this test. So it's literally, people have trouble, like how are they worded? What is the wording of the extra questions, or of the questions going to be? It's all multiple choice. Well, that's the wording of it, because those are actual questions. So see if it starts to make sense to you on those. By the end of today, it will, I'm sure. So, and that's the last time you're going to see me, probably forever. I'll probably be in the ocean after that. So on, how many people, again, are planning on taking the cumulative? So you'll see Susie, she's really nice. You'll see her on Monday, and she's gonna run. Well, she didn't write me back, but I think she's gonna run the Scantrons and send me the results so I can get those grades in pretty quickly. I'll run these Scantrons, Wednesday night, and by sometime Thursday, I should have them actually up. Definitely by Friday, I will. So you'll know if you do nothing. Let's say, because maybe you won't. You'll decide not to come in for the cumulative. It's up to you. Cumulative can't hurt you, but you'll see what grade you have up to that point. And that's on multiple choice too. Any questions? So, when it comes down to it, the major things that we covered in this chapter, and we can even put it here, we're talking about hypothalamic control, and mainly in this chapter of the anterior pituitary, and then target gland or tissue. And we really gave 3 examples of it, and we'll just we've done 2, and then there's a third one that's coming up. And so the first one we started with was CRH, release from the hypothalamus, controlling ACTH from the anterior pituitary, and then cortisol came. In this case, the target was the adrenal cortex. And we remember for all these, until we get to the end of today, it's a negative feedback homeostatic mechanism where the final product is inhibiting the first 2, so that we have normal control here. And we talked about, I'm not going to start off doing this, but we talked about conditions and how they would affect these hormone levels. And we sort of came to the idea that a tumor is going to cause an overproduction and a destruction, obviously an underproduction. And by playing the game, again, you can sort of see what the relative levels of the hormones are. And we're not going to play it right now, because I just want to make sure we get this review in. The second one actually has that up there, in which we did the thyroid. In this case, all the hypothalamic ones end in R8, because they're releasing hormones. You need to know all these acronyms, but they're multiple choice questions, so it's not a memorization. Is make sure you just don't reverse these and put ACTH up here. So in this case for the thyroid, it's TRH, TSH, and then the thyroid hormones are T3 and T4. Again, we have a negative feedback. Now let's look at this a second, because that's sort of what we ended on too. We did a lot on cortisol so that we could understand the system, but this has a couple extra things besides the idea of tumors in any of these areas or destruction. Because T3 and T4 are required, or 2 things. Let's go back a second. What that slide is starting to indicate is, or to illustrate, is that goiters, which is an enlarged thyroid, isn't just having too much, T3, T4. You can also have too little and still have a goiter, because the key with the goiter really is this overstimulation of these receptors, of these TH receptors that are on these follicular cells. The follicular cells are the ones that are controlling T3 and T4. And if you kind of go back to this picture again, the only reason I put this up is to indicate that these follicular cells have to do a lot of different things to produce T3, T4. So if you're stimulating these, even if you're not making the actual hormones, you are stimulating these cells to make all these enzymes, etc. That's what's causing the goiter. So you're thinking overstimulation of TSH receptors. And so besides the idea of tumor, 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 destruction, 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 here are two other cases you have to realize with thyroid hormones. One is, since the T3 and T4 require iodine, if you don't have iodine in your diet, the following is going to happen. Well, you can't make T3, T4. So your TRH levels are going to go up, and therefore your TSH levels are going to go up and hit those follicular cells. But because you have no iodine, you're not making it. So no negative feedback, higher TRH, higher TSH. It's this excessive amount of TSH hitting those cells, which is causing the goiter. You don't have much T3, T4. This is hypothyroidism. But the key is that the actual enlargement is not due to the hormone, it's due to this. TSH hitting those receptors. High TSH. The other case is the following, besides the normal one. So the other one here is a specific type of autoimmune disease called Graves' disease. And for this one, you actually, autoimmune disease, your immune system is recognizing your own cells inappropriately. And usually it destroys it. But in this case, you have these antibodies, these immunoglobulins, called thyroid stimulating. They act as TSH agonists. They are stimulating those TH receptors. And now you've got plenty of iodine, so the result is you're going to make T3 and T4, because you're stimulating these cells to make T3 and T4. We have plenty of iodine. So now you have a strong negative feedback. Remember, as these levels go up, these levels go down. And they do, because those tissues are working fine. And you're like, okay, hey, I'm not making TSH, no problem for me, but these guys, the TSIs, the antibodies don't respond to that feedback, therefore they're going to keep stimulating that, and you have a goiter. So the real key with goiters is not these levels. It's, are we stimulating those TH receptors, either directly with TSH or with sort of an agonist. In this case, it's going to be the antibodies that you produce. So we did one more example. This one, again, we didn't do much detail because we didn't need to. This was the third example in the chapter that you might have left. And for this, we're talking growth hormone. And what I said, and I still say, is we're not going to look at the idea of somatostatin and the control of that, because I want to make this nice and simple here. And so the third one is we're going to have growth hormone releasing hormone from the hypothalamus, the anterior pituitary, and all these look on answers if I'm saying anterior versus posterior, because we're going to get to posterior in chapter 26. All of these hormones we're talking about are going through the anterior pituitary. And this time, growth hormone, which is sort of the major one, is actually released by that. And instead of acting on one particular gland to produce another hormone, it acts on a bunch of other tissues, and of course, growth hormone, it's anabolic, right? It's building. But we need a feedback loop. And so there's something common that all these tissues are going to produce in response to growth hormone, and these are insulin-like growth factors, or IGFs. So to make this simple, that's sort of what we draw here. We have this idea of IGFs, and then we have the same idea of negative feedback. And you can play the same game, okay? Tumor, 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 destruction, 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 or, you can be taking, we'll do this for testosterone last chapter, you can be taking growth hormone, okay, for, to try to grow or to try to, make some records in some events for athletics. Some people will take growth hormone, build up muscle, things like that. And obviously you can play the effect of that as well, okay? Again, let's do that. If you're taking growth hormone, okay, to try to build up your muscle, etc., you expect what levels of these hormones? You expect growth hormone to be? IGFs to be? Growth hormone releasing hormone to be? Okay? You start with the problem or what you've done. You did this. Okay? That stimulates the production of, all the response of these tissues, production of IGGFs, the insulin-like growth factors. It's going to go back and inhibit this. And again, that should inhibit the natural production of growth hormone, but you're adding growth hormone, and that's sort of the key why you have high levels of growth hormone. Of course, if you can detect, synthetic versus, your metabolic ones, that's a good little drug test, so you really know you're also doing it. But that's what you would expect. So it's the same game. Those were the three. Okay? And just to put something over here, and then we're going to go over here, the only other one we're really going to put in chapter 26, so let's just put it over here, just for fun, and then when we play this, is we're going to see for sex hormones, the hypothalamus is going to release GnRH. We'll see what that is. We can write it down here. The anterior pituitary is going to release two things, FSH and LH. And the FSH is going to be responsible for gamete production. And the LH for the sex hormones. And that's coming up in a few minutes. So, really, that side of the board, this is what we've just done in this chapter. This is what we're going to do in a few minutes in chapter 26. That's the main thing from these last two chapters, is this, this basic hormonal control in which you have this sort of triad here, the hypothalamus controlling the master gland. This is the link between the nervous system and endocrine system. So hypothalamus controlling the anterior pituitary, and then these various target glands and tissues are going to respond, but we have a normal feedback loop that usually works unless you've got a problem.
Sorry, Mister, did you say for the growth hormone one, was that gigantism that you were...
Say the last part?
What was the dysfunction or the disease on the growth hormone one? Did you say that was, the down arrow for GHRH? Is that for gigantism that you were doing?
No, gigantism.
Well, no, I don't know what
No, it could be, I guess. I guess usually, I guess I'm talking more of the, where is this? More of Barry Bonds type thing. So that once, I guess if you took, I should have taken some growth hormone when I was growing up. Maybe I'd be a little bit bigger. But before growth, it could be, or it could be, if it's a pathology, it could be gigantism. Yeah. So I went ahead to Barry there for a minute. Okay. Now the other thing.
Oh wait, sorry, really quick before you continue. Where is GnHR?
It's GnHRH is going to be
the target, but like.
Just wait on this one. We're just writing it down. I just wanted to make it consistent because we're going to do this in chapter 26. Okay. So the other thing we did was to summarize calcium balance. And I put this figure up, but really, again, the way to do this, and we're going to do it over here, is to make it like blood glucose. So we have blood calcium. So either you're seeing this for a second time or you're seeing it for the first time here. So we're going to control blood calcium levels. And the reason that I put this figure up, although it's way too complicated, is that when we're talking about calcium, most of it's stored in the bone, okay? And the idea of this is that it's stored in the bone, but we're going to use it. So bone is constantly remodeling. We're going to be building bone and storing calcium using osteoblasts, and we're going to be degrading bone. I shouldn't say degrading, but basically degrading bone, dissolving bone, and releasing calcium using the Pac-Man osteoclast. So depending if we need calcium or not, we're going to be, again, either storing it in the bone or taking it out of the bone. And so that's why I have this picture. Don't go crazy on it. But the other two things are, the other two ways that we control calcium is we can control how much gets absorbed from our diet, that's up there, and the kidney, of course. How much gets reabsorbed versus excreted. Those are the main three areas that we're controlling calcium levels. And we're going to have 3 hormones doing this. So we have 3 hormones controlling this process. And we're going to start down, because there's 2 of them down. Okay? So if you have too little calcium in the blood, so hypocalcemia, there's going to be basically, and I'm even going to summarize it a little bit more in a way. Well, no, I'll do it the same way. So the first hormone we talk about is PTH. So we have the parathyroid gland, okay, which is near the thyroid gland, and they're going to produce PTH. And PTH is going to raise blood calcium levels. So hypocalcemia, we make PTH. It's going to raise it. Don't forget negative feedback. 1, 2, 3. It's going to raise it all 3 ways. Okay? Every way that you can think to get calcium in, it's going to do it. So we'll write the first one. It's going to, it doesn't exactly matter exactly how I write it, but it's going to increase the activity of the osteoclasts, so that we will, help dissolve bone, and therefore, I'll use the old word, release calcium into the blood from the bone. Remember, our goal is to raise calcium levels. So just remember that cell type to do it, but we're getting it from the bone. Then it's going to do the other 2 things too. It's going to increase absorption from the intestine, and increase reabsorption from the kidney. Okay? That's PTH. That's the main hormone that's responding to low blood calcium. Its attempt to raise blood calcium by getting it, increasing its efficiency from all 3 areas. We're going to get it from the bone, activating the osteoclast. We're going to absorb more from the diet, and we're going to reabsorb more from the kidney, reach homeostatic levels, and then negative feedback. There's another guy under here. So the other hormone we're putting under there that's sort of assisting PTH is actually a derivative of vitamin D called calcitriol. And so calcitriol, I'll put it on this side. So calcitriol, again, vitamin D3.
Does that response at the same time PTH does?
Yes. Okay?
Okay.
So it's going to respond at the same time, as, basically. And again, here you can sort of see the factoids. It's made in the liver and kidney from vitamin D. You get vitamin D in your diet, you get it from sunlight, and then they convert that into the active form here, calcitriol. So, and again, calcitriol is basically doing the same thing. Now, if you look at it in reality, it's only doing 2 out of the 3. Okay, it's not actually affecting the kidney reabsorption. It's increasing it, getting from the bone and from the from your diet. But I don't want you to sort of focus on that. I'm not going to try to confuse you. I want to state it because it's a fact. But all I want you to know is that these 2 hormones, PTH and calcitriol, are responding to low blood calcium, and they're going to increase it by these 3 mechanisms. So I'm not going to try to go, which one doesn't calcitriol do? I mean, it's like a stupid little point as far as what we're trying to do. It's simply both these hormones are working together to raise blood calcium levels by getting them from these 3 places. And that's all I want from that. Any questions about that?
What if you don't have PTH but you do have calcitriol?
Then it will be less sufficient. Okay, basically. Same thing the other way around as well. If you don't have enough vitamin D, then it's going to be, so both of them, again, they work together. So the other's going to have to try to compensate, basically.
For our other ones that we did, we were talking about where the site of the hormone is. Do we need to know that for this one?
The,
The
parathyroid gland, yeah.
I mean,
That's it.
and that's just a gland.
Yeah, just a gland.
Just a gland.
Now, the last one. That's just another picture of it.
Kidneys, you know?
It's not the kidney. I mean, then we'd be like going crazy. The kidney's involved in everything. Look, calcium. All right. The guy at the top, if we have high blood calcium, we need to lower it. There's one guy. Unfortunately, it sounds a lot like the other one. So calcitonin, you do need to know it's from the C cells of the thyroid. The thyroid had follicular cells, which we've already dealt with here. These are the follicular cells of the thyroid. The C cells of the thyroid make calcitonin. And calcitonin is going to basically do two of these three. Again, don't worry about the one it doesn't do exactly, but they all involve the bone. It's going to basically take in calcium. Okay, it's going to. We have too much blood calcium. It's going to store it in the bone. So osteoblasts, it's going to be used to store calcium in the bone. And it's going to, I don't know which way I want to write it. I can write it both ways. It's going to decrease reabsorption / increase excretion. This is the kidney of calcium by the kidney. It doesn't actually affect absorption from the intestine. But again, don't focus on that. I'm not going to make some little point. Which one doesn't calcitonin do? All you have to realize is calcitonin's up at top. It's produced by the C cells. It responds to hypercalcemia. And again, everything involves the bone. It's going to activate osteoblasts, store it in the bone. You're going to store it in the bone and excrete it in the urine. That's going to lower blood calcium and then negative feedback.
Above calcitonin, is that a C plus cells thyroid?
It's C cells. I don't. Sorry. I think I wanted like a dash. Sorry. I don't even know if it uses a dash. Let's see if it does. Just out of curiosity. It doesn't even use a dash. So it's nothing. So again, here's the picture of the thyroid. Here are the C cells that secretes the calcitonin, and then these are the famous follicular cells involved in the T3, T4. So this one is like blood glucose, okay? Unlike everything we've done in the chapter. So this was there was 4 things in the chapter. There was cortisol, thyroid hormones, growth hormones, and then calcium balance. But calcium fit over here.
And are there like 8 scenarios for each, or?
See, everyone with these numbers, it's like there's 6 to 8 depending on, if you're talking like for cortisol, I mean, there's only 6. Everyone gets the 6, right? Tumor, 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 destruction, destruction, destruction. Some of them have extra ones, like you could be given cortisol or you could be given growth hormone, or for thyroid there was at least 8 because you had Graves' disease and iodine.
Yeah.
So,
I just don't want to miss any, but also.
I know. Did you add them all up?
Yeah, I have them. Hold on.
Let me take a drink. There's 32 and a half scenarios. No, what is it?
Okay, so for thyroid hormones, there's 8. For cortisol hormones, there's 7. And then for growth hormones, there's 7.
Well, thank you.
You're welcome.
Okay, last chapter of the course. So why is sex fun? I have no idea. Wrong course. But we're gonna do this chapter. It's not my best chapter. Okay, I'm doing a very short one. There's a lot more in the chapter. I sort of tried to just get through it. Okay. So first of all, is this a boy or a girl?
Girl. Sorry, it's a boy.
It's a boy.
Well, we'll see. See, we'll see, because so we're not going to make you do a karyotype, but here are the sex chromosomes. If you're a girl, you have 2 X chromosomes. If you're genetically a male, you have an X, and you've got a little bitty nub of a Y. Look at this, cute. Okay, it's just a little bitty nub. It doesn't have many genes on it, but it has an important gene. Okay, and this is very interesting. You can be genetically a male, but develop into a female. Okay? So let's show you how. Okay, and then we get to the last 4 or 5 slides of the course. Let me kind of do over here to make it. This is pretty. I didn't really know this, so I did it. So again, you can kind of see this idea that 6 weeks or so, all the reproductive glands have this bi potential. Okay, depending upon what happens next. No matter what genetically you are, what happens next is you can develop into female or male. And I'm trying to limit how many times I say genitalia today, but and we're not memorizing all these things, okay? And I'm not going to say all these things, but you can see where we're going there, okay? Now, the 2 things we're going to have to know that I can actually say are these guys. Okay, so because we're going to show you how this happens. So the Wolffian ducts are responsible for sort of the idea of becoming, to develop the male parts. Okay, the Mullerian ducts are for female, and Wolffian sounds male to me, so I remember those. So Wolffian and Mullerian. Remember, you're not even doing these for.
It's responsible for the development of male and female.
Yes.
Development.
Okay, we're going to show you how. So here's the key. And I'm going to make, here's listed in a flow chart, and we'll see their flow chart. So this is the idea of that to actually develop into male characteristics, okay, phenotypically male, even though you're genetically, this has to happen around 6-7 weeks of development. You're going to have to actually activate a region of that Y gene, of the Y gene, chromosome, which is very, very, doesn't have many genes on it, but it has something called the SRY, which is the sex-determining region of Y. That has to be activated, which means we have to actually make a protein, at that stage to actually have this happen. And so you're going to have this SRY become active, the sex-determining region of the Y gene. It's going to make a protein called TDF, testes determining factor. And then we're going to make a bunch of other proteins. The key with this is, if this happens, and this has to happen at that right time, you're going to make the testes.
So TDF cannot be formed unless SRY is active.
Yes, exactly. You need to turn on the gene, make TDF, and then it's going to make some other proteins, etc., that will end up producing testes. Now the testes themselves produce 2 important substances, and I'm going to make one of those little branches here. The first one's down at the bottom. It's going to convert or make AMH, which, as you can see, stands for anti-Mullerian hormone, because we want the regression. If you're going to be male, you don't want female parts. You want the regression of those Mullerian ducts, and that's what anti-Mullerian hormone does. So the testes make AMH to cause regression of those ducts. And it's basically going to make testosterone and a derivative of testosterone called DHT. Okay, so testosterone and a derivative. We'll show you there's an enzyme involved in that. Now, testosterone is basically important for the Wolffian, I don't know who named these, the Wolffian ducts to develop into sort of internal male genitalia. Say it a couple more times. Okay, so again, to have, where is this? To basically go this way, okay? So you can read all that.
You're saying the internal?
Internal.
Yeah.
So just the development of the Wolffian ducts into those structures.
The structure.
There, yeah. You want me to read all those? No.
No.
I don't want to read them all. Okay? Now, the idea of this is, though, and this is sort of a kind of an open thing, the DHT is necessary for what they're calling sort of what you will see. So external features.
Okay.
And that has a particular enzyme. In fact, let's show that slide and we can come back and see it. So if you look at sort of and remind ourselves that all these different hormones are coming from cholesterol with different enzymes. And so if you have testosterone, so you're making testosterone fine, but you're missing this hormone, 5-alpha reductase, you're not going to be able to produce DHT very efficiently. And so what will happen in those cases, and it kind of says this here, is you're genetically a male, okay, and you don't have female parts, you have male parts, but your external features don't show that. They're sort of ambiguous because you're not producing DHT at that time. And do I know a lot about this? No. I did look up because I'm like, okay, well, let's see what these people look like. I looked up, sort of saw pictures of them, because luckily Google works. And, it's sort of, visually they're sort of ambiguous looking, okay? In the sense that you can't really tell, do they have breasts or not? Is it, I guess I'll just say this once, is it like, a penis or a clitoris? It's sort of in the middle, and so it is sort of ambiguous sort of idea. Now, again, it says at puberty, obviously then more of this will kick in. I actually think once they determine this, they'll give hormones a little bit earlier to kind of get this stuff, happening a little quicker. Like, well, you got to wait till you're 13. Sorry, wait a minute. I want a drug right now. Okay? Anyway, that's the idea. So, and again, this is sort of interesting. The idea is that genetically you could be a male, but if this doesn't happen, if something's interfering with this, so that you're not making testes, then you're again, we kind of put this. Let me just show this. Well, let me show this. The next two slides, and then we can say this. This is just saying the same thing as I had, but I want to show it using their slide. So to become phenotypically a male, okay, we already have genetics. We need that Y gene to become active, the SRY, that particular region. We're going to make the testes determining factor. It's going to basically help us make a lot of things to make the testes. You don't need the cell types, but the testes are going to make AMH to get rid of Mullerian ducts so that female parts won't form, and testosterone and DHT to get the Wolffian ducts developed. Okay, so it's the same type of idea. The way it lists for female it's sort of a default pathway, even though it's more complicated than this, but that's all we sort of have to go. If you don't have AMH, so remember, if you're female, you don't have a Y gene, you don't have TDF, and you are not going to produce testes because you don't have the Y gene, you have the X. So you're not going to make AMH, therefore your Mullerian ducts are going to develop into that, okay? You're not making testosterone or DHT, so that means your Wolffian ducts are going to go away, and you're not going to be male, basically. And that's what normally will happen, okay? So females don't have the Y gene, and that's what will basically happen. Their Mullerian ducts will develop, their Wolffian ducts will go away. But again, it's sort of interesting. I don't know how many people knew this. How many people knew you could be genetically a male, but you could become phenotypically a female? That's pretty many. Okay, I didn't know this. How many people didn't know this and are like, whoa? I was like, whoa. Okay.
Wait, how can you get Mullerian ducts without testes?
Because if you have testes, your Mullerian ducts are gonna. Let's just go back to this. So, right now, you're at 6 weeks. You've got all this, okay? You've got the Wolffian ducts and the Mullerian ducts with the potential to go both ways.
Okay.
So, if you are female, you don't make AMH, and so these develop. Because, when you have testes, you produce anti-Mullerian hormone to get rid of them. So, so without testes, you're not going to make AMH. Okay? If you don't make anti-Mullerian, you're going to develop into the female. Okay? Without testes, you're not going to make testosterone, so you get rid of the Wolffian ducts. So the key is for female, you're missing testes, which allows the Mullerian ducts to develop and gets rid of the Wolffian ducts because of these two products here.
So you don't make AMH.
Right, you're not going to make AMH, and you're not going to make testosterone. So without AMH, the Mullerian ducts develop. Without testosterone, the Wolffian ducts go away.
Is there a way to sway that? So if you get pregnant and you want a girl, do they give shots or something to make you have one? You mean you're gonna have a genetic male and you want it to turn into a girl? Yeah. No, not me. I'm just saying if it's possible. I'm not pregnant, no.
I haven't heard of, because usually it's the other way around, at least in parts of the world, right, where being female is sort of a problem. But I haven't heard of that.
Oh.
I haven't heard of that. But theoretically, sure. Okay.
Like to determine the sex of the baby, that's possible, right?
Now just to determine genetically and to pick an embryo that has that, you can't do it by in vitro fertilization. Although in some countries it's actually illegal to do that. It's actually illegal in countries like India and China to actually, when you're doing in vitro fertilization to actually choose the sex. Here it's legal. So you can, you go to clinics, you can choose the sex of your baby, male or female. In those countries, because it's been such a problem, this anti-female sort of culture in some of those, it caused such a sway of the population.
Yeah.
They actually made it illegal in a lot of those countries like China and India, and actually even Great Britain. This was from another class, but you'd be amazed how many of these other countries, and yet we, which sometimes seem very sort of Puritan, but we can actually, if you go to clinics, you can actually still choose the sex of your baby that way. So you can do it that way. I don't know about throwing some hormone on there. That would be really weird. Okay.
Wait, how do you? I guess I never realized that you could do that. I thought because you don't know until development until 6 or 7 weeks.
For which thing? For choosing sex?
Yeah.
No, we're talking genetically now. So genetically, for in vitro fertilization, you basically, you're going to make in vitro like a bunch of different embryos, right? And then they genetically test to see if you have a disease, but they can also then determine the karyotype and determine which ones are male, which ones are female, and you can choose which ones you want implanted. So you can literally choose the sex of your baby. Most people don't. Most people are using it to make sure they're disease-free, especially, in fact, we'll kind of go to that too. The older the woman's having a baby, the more genetic, more downs and all that. So they're usually doing it for that, in conjunction with the idea that they can't conceive naturally. So they're doing
like
both of those.
Women?
Well, I don't mean older women, but I guess older women.
So we don't have, I know we don't have an S or a Y because that's the Y gene, but we have an X, females have X genes, but we don't have a special acronym or anything.
What's the
Like SRX?
the male, the female breakdown? I think that's
The
what we
female.
asked.
Well, right now that's the idea, and that's why. Let me just. Where is this?
You wanna know what
Here, and this is just not. It needs to be updated probably and gets more complicated than it really is. Here it's saying it's a default pathway. So by not, because you have all the, you have those, all the Y potential structures. Without a Y gene, you're not making these things, okay? And so because by not making them, this is going to happen. You're not going to have testes. So if you don't make an AMH, your Mullerian ducts will develop, and they do. If you're not making testosterone, which you're not, the Wolffian ducts go away. So it is sort of, in this way, a kind of a default. It's listed as a default pathway. Okay? You've got 2 X's, okay? I wouldn't complain.
So in the beginning, the photos that you showed, why did they have a male and female parts at the same time?
Because all they're saying is they're just saying that has the potential at that stage to go either way. Depending upon these conditions, what hormones are exposed to at around that time, they'll either develop female or they'll develop male. So these sort of, again, so here are the names of sort of the embryonic structures, what they're called, and depending upon what we're saying, they'll either develop into the female or the male. Okay? Yeah.
Do males and females, like if you're a male, you of course make testosterone, but then how ladies go through menopause, do they also make testosterone, but mostly estrogen dominant, and then it won't?
Men make estrogen too. So
Right, 'cause
yeah.
I've seen that with age, the older men end up looking a little more feminine, the
Hey.
older ladies
What are you trying to say to me?
I'm just saying, right?
That's how we say he's all bald.
You're not on a borderline grade, are you? All right, no. Yeah,
both, right, but more dominant,
yeah,
okay.
without a doubt. It's just that now we're talking about a critical stage of development. Okay, so we're talking again 6-7 weeks. Those hormone levels determine which way things are going to go, and that's it actually is scary in a way. To me, it sounds scary that it's that dependent upon these hormone levels, and different things can cause these hormone levels to change. But I guess it works out okay for most of us. Any other questions? You guys like to torture me on this last thing, okay? Yeah. What more do I need to tell you about male genitals? Go ahead.
it seems with the male pathway, there are like 5 different instances in which it can quote unquote go wrong. Are there names like for, not that you know them of course, but are there names for every step in which it could not
Yeah,
work?
I'm sure there are. And again, you can have it. You can, you look at hermaphrodites, which have both. Okay, if you develop the testes, but just don't make AMH, okay, that means the Müllerian ducts will develop and the Wolffian ducts will develop. So you can have both development. That's like hermaphrodites. But yeah, I don't know, other ones, okay, that they're called. But yeah.
So that's the six-week process where something could go wrong, and that's how it comes about, right?
Hey.
You know, like I said, in the 6 weeks, that's like where the
Yeah, exactly. You could think that if women, now if you look at this, and again, I don't know all the studies on this, if let's say women are at this stage and they're taking a lot of testosterone, okay, do you see how that could then influence the, if they're not going to have testes, that might, it seems like it would influence the percentage of hermaphrodites, or at least partial, because if you have testosterone, you are going to actually get these some development of the Wolffian ducts, okay?
Like the mother?
Yeah. We're talking about mother during pregnancy at 6 or 7 weeks. What you're exposed to during pregnancy, obviously we already know males are a lot. So these levels of hormones, and again, you can get exogenous testosterone without a doubt. And so, yeah.
I didn't know that.
Yeah, it's crazy.
So you can sway the sex then?
You can,
if you
but,
have-
but remember, we're swaying the phenotypic, so the development of the sex. Yeah, but you still have the genetically
Genes,
the
right.
the male versus that. Excuse me. When you have testes, is that what you're saying? Wait, I can't hear you. Yeah. Yeah. No, look, this only, the only way you're going to get testes is if you have a Y gene. Okay? I've never heard about injecting themselves with TDF, right? So the only way you're going to get testes is if you have a Y gene. And that part of the Y gene gets activated. Okay? And then that's going to happen. So if you're a female, you're not going to have testes. All that might happen is you might affect these hormone levels by giving yourself testosterone, or not, right? So males are the ones that are kind of freakier, right? Because males will develop this. It's genetically a male, you have this, but here is where that could be messed up. Because even though you have a Y gene, if something doesn't turn on or if something doesn't work here, even though you're genetically a male, you're going to be phenotypically a female. And remember, there's been athletes, right? They tested others as tennis player and all this stuff.
Oh, yeah.
That are genetically male, but they are female, and they are female. I mean, they have, they can have babies. Everything is like, they're not like having sex changes or anything like that. I mean, they just develop that way because of, and again, I don't know what those persons have, but somehow this process got interfered with. So that's the only thing the Y gene is there for, really. There's very little else on that Y gene, okay? There's like, watching football and, spitting or something, I don't know. But there's not much else on the Y gene besides that. So it needs to be active at that time. And it's pretty interesting. But we're moving on, aren't we? God, I haven't got to breastfeeding yet. Okay. So, we've got like 4 things to do. 4 things to do. We have to explain this, okay? Mainly talk about males, and then the 3 positive feedback loops of for female reproduction. The reason I put this up is we're not going to go through the whole meiosis process or anything like that, so don't freak out. But there's a big difference between gamete production for men and women. And so for men, here's the idea of making sperm, spermatogenesis. And once puberty hits, it's like we're going to make sperm. Okay, we're going to make sperm today, we're going to make sperm tomorrow, and next week we're constantly making new sperm. We're constantly making those new gametes. And that seems fair. Now here's the interesting thing, and most people know this, and most females definitely know this. As a female, you have actually made all the eggs you're going to have prior to birth, and it begins this process of meiosis, the formation, maturation of this, and stays in stasis. Okay, so you get stuck in meiosis 1, before birth. All your eggs are there, and then at puberty, 1 egg at a time is then going to be allowed to develop and continue meiosis and complete maturation. And so that means those eggs are sitting there for a long time in stasis. And that's why the older a woman is, especially when you get to 40 and beyond, the rates of Down's disease and other genetic diseases go way up, because those things have been sitting there in that sort of state of being stuck in meiosis 1 for that long time, and there's simply more and more things that start going wrong at that the longer they are. Now, why that is this way, I don't know. I mean, there probably is some explanation. It seems kind of crazy to have it that way, but there must, I don't know much.
So we have all our eggs at birth?
Yeah. All your eggs are birth, not only do you have them all, but they're already started to go this process of meiosis, and they get stuck at a stage in meiosis 1. Okay, there's 2 stages of cell division, which you may or may not have had for forming gametes. And so for men, it's like, they're constantly making sperm, constantly going through, starting from the beginning and going through meiosis, making sperm. But for females, all the eggs are prior to birth, and they actually begin meiosis, and they stay in meiosis 1, puberty. 1 egg, obviously a month, will then be matured into a mature one. So it seems odd to have it that way, but again, I'm not God, so I don't know. I just ride my bike and come here. So there must be some reason for it, evolutionary reason or something like that. But the bottom line is that's a little different. Okay, and so when we talk, we're going to talk a little about that when we do ovulation. So that's why I wanted to put that. All right. So we already know the sex hormones. So this slide we're going to pause on it a second, but we're not going to use this slide. So we're going to have the same idea here, and then I'm going to go through this. Now we're going to have, for male and female, we're going to have we're going to have the hypothalamus make GnRH. The anterior pituitary is going to make 2 different hormones. FSH, which even here it says in there, it's going to be involved in the relative gametes, sperm or egg maturation. That's follicle-stimulated hormone, we'll see. LH is going to be basically mostly for the sex hormones, luteinizing hormone for the sex hormones. But you already see a problem there. You see these dot, dot, dots, okay? So females with the dot, dot, dots are more complicated than males. I mean, like way more complicated. So let's do a simple male. Okay, so we're going to look at the male one, and then we do the 3 positive feedback groups of female. So if you look at the male, which is going to be much simpler, you see a very similar thing that we've seen before. So now we have this. Okay, so you have the hypothalamus making gonadotropin releasing hormone. Okay, I guess I don't have that. Let me go back to this. Say that again?
What are you describing? What GnRH is?
Yeah, thought I put it up there. It's gonadotropin releasing hormone. But of course you don't have to. Gonadotropin.
Gonads.
Releasing hormone. Okay? But GnRH for us. So it's going to go to the anterior pituitary, and now again we have 2 hormones being released, FSH and LH. Okay, remember, you don't need to know the cell types for me as far as these folks. But LH is involved in testosterone production. And if you look at testosterone, so let's actually, now we're going to do male. So we're looking at testosterone. So luteinizing hormone, or LH, is involved in testosterone, and it has, nice and simple like all of these do, negative feedback. As you're producing testosterone, it will come back and have a negative feedback on both LH and GnRH. Okay? All that looks the same. GnRH, LH, testosterone, negative feedback. Everything we've done, right? All right. Again, we're on males here. We're male. Because I'll probably have to erase that and get that. So here we're going to make sperm. So spermatogenesis, okay, FSH is going to be follicle-stimulating hormone. FSH is then, through a bunch of ways, is going to stimulate spermatogenesis, making sperm. So we have an issue here. Do you want your sperm to swim around to your hypothalamus in the blood?
No.
But do you want some sort of feedback loop? Yes. So at the same time that we're producing sperm, we produce something else that can circulate in the blood, cleverly called inhibin. And so we're making sperm and, again, the molecule inhibin. Inhibin comes back, and look what it does. It only has a loop, it only inhibits FSH. We're going to control sperm production a little separately from the hormone production. And so it has its own separate loop.
So is that what goes through the blood to signal and tell them stop?
Yes. So because again, you can't have the gametes going through the blood, so you need something to sort of mark with them to be sort of their surrogate. And in this case, it's inhibin. So you're going to be making sperm and inhibin. Inhibin circulates in the blood and goes to the anterior pituitary, inhibits FSH. So that we're controlling sperm production. A little separately, then we're controlling testosterone. Testosterone is going to both the hypothalamus and anterior pituitary, like all these other ones did, and inhibit those hormones.
Inhibits sperm production, you said? Goes to FSH.
FSH.
Goes to FSH to control sperm production?
Yeah, right. FSH, but inhibin will go to inhibit FSH to control sperm production. And it's this simple, okay? Men are simple, this is how it is. It's just like all these other ones, and you could do tumors, and you could do destruction, and of course you also can do, I guess, the seventh one here, because you can get anabolic steroids. Again, we have athletes, etc., that will do that. And so if you're given anabolic steroids, what do you expect the levels of these hormones to be? Low, right? If you have too much testosterone, low, low, low. What do you think sperm count's going to be of Barry and all these other people?
High or low?
Low. Okay? So if you're on anabolic steroids, you're building up muscle and all that stuff, but all of this is being inhibited greatly, okay, including sperm production. What I teach, well, at least I used to teach some exercise phys, talking about anabolic steroids, and I'd put the side effects, I'd put something called testicular atrophy. And most males will sort of cringe at it. So you will basically, if you take steroids, you really are causing some problems in this whole reproductive area here. But you're hitting home runs, so I guess it's up to you. So everything else is the same, exactly like we did before. Okay, tumor, 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 etc. You take a drink. Okay. Now, every instructor will emphasize different things in their course, right? What do I emphasize? Kidney, okay? I could go through, we could spend a couple of days on this and stuff like that, but I can't really handle it, and I'm not going to. So we're going to show you what I'm going to actually spend on this. But this, again, for females, this is sort of like, yeah, you've known this for years, it's no big deal. For males, it's like, I don't know, it looks pretty foreign to us. This is, what is this?
What is it?
It's everything that's going on through the monthly cycle. So this is, yeah, you see hormones and that and this and okay. So, and again, it's a very complicated process. It's one I don't fully understand, but we're simply not going to deal with it except for one thing. So the last three things of the course involve female and positive feedback loops. Negative feedback loops, homeostasis. Positive feedback loops are going to be something which increases, increases, increases until something stops it, something external. So you want something to happen fast. You don't want it to be in some sort of, homeostatic level. So the first one of these is only going to emphasize out of this whole cycle ovulation. Because you're going to see we're going to have this idea of a positive feedback loop for the ovulation period of a couple days, in which it's, well, let me just kind of put this here. And again, even this is more complicated than I'm going to make it. But if you look before and after, so if you're looking at these periods here, for the most part, it's working the same with negative feedback. For the most part. But we're not going to deal with the little things. So for the most part, it does. But look what happens at ovulation. You're going to have these hormones here, which normally should inhibit, actually stimulate. So if you look at the process of ovulation only happening within these couple days, again, don't try to worry about these cells, you're going to have this idea that you're going to be producing the hormones, estrogen and progesterone. But instead of inhibiting GnRH and OH, they're going to stimulate that. Which means what? More GnRH, more OH means more estrogen and progesterone, which means what? More GnRH, more OH. We have a positive feedback loop, okay, instead of our normal control. And it's going to happen until something happens, and that will be pop, ovulation. Once ovulation occurs, everything goes back to a negative feedback. So that's why, again, ignore it. Again, it's even more complicated, obviously, than I'm saying here. But really, you look before and after this, you have this idea of normal homeostatic control, where these products, and we'll actually write this up here, that these hormones will inhibit. But during this one stage we want it to happen, it's a positive feedback loop. You have this luteinizing hormone surge. You can actually see it go up here. That's involved in causing this ovulation to happen. So if you kind of look at it here, so I can basically do it this way. So overall, again, a simplification, but humor me on this. If you look through sort of non-ovulation versus all I really care about is, when you're trying to study this, is the ovulation. So non-ovulation, ovulation doing this. Okay, for non-ovulation again, you have GnRH. It's just like males. We're going to make FSH and luteinizing hormone LH. FSH is going to be basically involved for egg maturation, and it's a lot of different steps to that. And LH for estrogen, progesterone. Although there's some, there's complication with that too. Estrogen, progesterone. Guess I'm going to have to move over here. So, in most situations, except for ovulation, you're going to have this idea where estrogen, progesterone is going to come back and have negative feedback on GnRH and OH, just like testosterone did. Yay. We also have this idea of egg maturation. Again, for egg maturation, do you want those maturing eggs to go up to the anterior pituitary in the blood?
No.
So guess what? It makes the same substance, okay, throughout. This is inhibin. So you're going to have inhibin. Okay? And that's going to control egg maturation. So we don't want more eggs maturing at once, right? We're trying to control one egg. And so as the egg is maturing, it's inhibiting FSH. We don't want anything, it's controlling egg maturation, just like that controlled sperm production. Okay? And that all seems normal. It kind of is. Now, when you go to B, you have this. So for ovulation, you basically, again, a simplification, we'll have GnRH, okay? You have FSH, and this stays the same, basically. You have, your egg maturation process, inhibin. So if you look at that, that's staying negative, okay? Even though we're having this luteinizing hormone surge and all that to have ovulation, we don't want more eggs to mature or develop, and so FSH still stays low. But now these hormones, let's get rid of that. So again, LH, which controls the estrogen progesterone, they have a positive, okay? The estrogen and progesterone during ovulation now is going to cause more GnRH and LH to be produced, which causes more estrogen and progesterone, more OH, or GnRH, LH, until ovulation occurs. And then things will go back to basically normal, and then if you get pregnant, a lot of other things happen too. Okay, so again, there's a lot in the chapter. You can deal a lot with more than we're going to deal with, but we're not. Okay, we're only dealing with, as far as this whole cycle goes, sort of these hormone levels, and really just looking. You're not going to have to know A, B, C, and D. Look at all this stuff. All you really have to realize is B. Okay, that's all I'm concentrating on, is what happens at ovulation.
I feel like you keep saying it's positive until ovulation occurs.
It's all this is negative. Oh yeah. In other words, this is going to be a positive feedback loop until the process of ovulation occurring, which is
But isn't that like a couple days?
yeah.
So, but
And you can see
when,
this.
When okay, I'm
And
just.
if you look at these like hormone levels, you actually see there's a slight, again, it gets real complicated. There's a slight difference between LH and FSH, where they go up, but they do go up, and you can see this is taking a couple of days. So it's building up, and building up until that actually happens. So it is a couple-day process that you have this positive feedback loop.
Okay, and that's what I was just making sure, because before ovulation still means non-ovulation, but you meant like in a couple-day period, that's like considered the ovulation period.
Yeah,
like,
exactly.
Before the eggs actually like release from your ovaries to like.
Right, and starts developing into a follicle. Okay, so all that's happening
Yeah.
during those first, and that's when everything's sort of controlled and negative feedback and that type of thing. And then during this period between these lines, which are a couple days basically, that's when you have this positive feedback loop in B, which is this is building up at these different levels, and you can actually see them here. Again, you can see even it's a lot more complicated of where exactly within that period it builds up, and it's like crazy complicated. But for us, we're going to make it as simple as we can, okay, and make it just that. Yes? And we move on from ovulation to, well, I guess I got one thing. For pregnancy, I'm not doing all that's happening in pregnancy and the development, corpus callosum, whatever, corpus luteum. Yeah, I'm just not, sorry. But I do want to mention there's one more hormone, and then we do the last two slides. So HCG, you can see what it stands for. So if you are pregnant, you need to continue making progesterone, and so the placenta will secrete this, so that progesterone will continue. So, anybody remember this guy? Because now it's a couple years old. So Manny was accused, or actually got tested, and he was positive for HCG. Was Manny pregnant? This is why Manny supposedly might have taken this. All right, so the idea is when we said you take anabolic steroids, remember we said all of these levels of the hormones were going to be what? Low. Okay? Well, that's sort of a sign when people are testing you that you've been on anabolic steroids, even if some of these have gotten out of the system or you figured out a way to get them out, is that you have low levels of these compared to normal. And again, I don't know the mechanism, I haven't looked that up, but HCG basically boosts these back up to normal levels. So it's sort of a combination of you'll take anabolic steroids and then you'll do whatever to try to clear them from your system, but HCG then will get these levels up and it will appear that you haven't done anything except that you got levels of HCG, and why is that? So, yeah, that's that. So, a lot of weird things happen when you're trying to play baseball, I guess. Okay? Or win Tour de France's, okay? So, whatever. Okay, last two slides of the course. And there are doozies, right? Let me take a drink. So, 3 positive feedback loops are what ends this course. We have ovulation. The second one is going to be childbirth. Okay? And for that, I guess I can do it this way too. We're going to deal with oxytocin. And back at the chapter 23, we remembered, and I'm going to kind of put this, that we're going to use a different part of the pituitary now. So we have the hypothalamus, we have the posterior pituitary.
Is this for childbirth?
Yeah, this is for childbirth. And in fact, let's just look at that one second, because it's been a while. Where's my 23? If you go back, so if we go back to chapter 23, we showed this in the beginning, and now we're dealing with it now. All the other ones that we dealt with, okay, since then, have been that we have this, the hypothalamus produce a hormone, okay, like these guys up here, these releasing hormones. They go through the portivessels to the anterior pituitary and release these various substances, right? And then that's what we've been doing. For the posterior pituitary, there's only two things that are made, okay? These are called neurohormones. And so the reason they're called neurohormones, when we look at them, these substances, which are just ADH and oxytocin, they're made in neurons of the hypothalamus. But those axons extend to the posterior pituitary, where these are released just like neurotransmitters, but instead of binding to a target right there, it goes into the blood like a hormone. And so these two, ADH and oxytocin, are actually classified as neurohormones. They have characteristics of both. They're made in nerves, but they're released into the blood. And so those are the only two neurohormones we're really dealing with, ADH and oxytocin. What does ADH do?
Salt increase.
Water reabsorption. That's aldosterone you're thinking of, okay? But oxytocin has these targets, which are going to go to the last couple slides of the course. Oxytocin is going to circulate and affect uterine muscle contraction for childbirth, and then the last slide, it's going to affect the milk injection, for breastfeeding. And that's how we end the course, was breastfeeding. So let's look at those last two slides.
What did you say about the axon of the nerve? For neurohormones?
The neurohormones, it's like, all the other hormones we talked about releasing are made in the hypothalamus by nerves, but then are released through the blood. These ones, the axons actually travel to the posterior pituitary, and that's where these hormones are released into the blood. So that's why it's like a neurohormone. It's like a neurotransmitter we release, but it goes into the blood to a target distant, which is like a hormone. So it looks like that. So, and mainly again, we know ADH. The last two slides we're only talking about oxytocin. What is its role in childbirth and then in breastfeeding-ish stuff? Okay, so it's a pretty good way to just show it here, and you can put it up there. So here's childbirth in a simple format. The idea is that basically, baby's is dropping down here. The cervix stretches. It's going to have a nerve go to the hypothalamus. Going to cause oxytocin release from the posterior pituitary, just like we showed. It travels to the smooth muscles of the uterus, causing contraction. That's going to cause further drop, further stretch, further oxytocin, further contraction. Do we want this to be homeostatic?
No.
No! Sounds like a bad idea. This is a positive feedback loop. So we have more oxytocin, more contractions, more stretch until pop, baby born. Remember, it takes like an external event. We had ovulation stop it. Now we actually have childbirth stop this positive feedback loop. So the second of three positive feedback loops involving oxytocin. Okay? And again, oxytocin, the target now is the uterus, smooth muscles, causing contractions, and we want more and more and more until this thing happens. So congratulations. You've ovulated, you've had a baby. Now what? Okay, for some reason, the last line of the course is this baby breastfeeding. I have no idea why. It's always a weird way to end the course, but that's how I'm ending it. And so I'm going to say it and then talk. I'll probably write it on the board. So positive feedback loop is we want this baby to be fed. There's going to be two parts to this. I'm going to just say it and then put it. This is the end of the course. Is we want to make the milk and we want to eject the milk. We want that to be very efficient. And so we're going to sort of have two pathways here. Let me just kind of go through it here and then do it again on the board. I always wonder how to actually do this. I might actually have to do it this way. So the first thing, and I want to write this up here too for a second. Let me go over here. I'm going to go through the loop first of how to basically basically milk production and secretion into the ducts, okay? And then I'm going to go into actually injection. And to do this, I have to sort of, all they have is PIH up here. You need to know what that is. PIH stands for Prolactin Inhibitory Hormone. Okay? So, if you look at, let's say, non-lactating. So non-lactating women, and you go ahead and do the hypothalamus. This is going to be the anterior pituitary. And the target with this right breast. I'm going to go to the specific parts. And so the idea of this is the following for this one. That normally, if you're non-lactating, you don't want to make prolactin. So prolactin is going to be the hormone made by the anterior pituitary, going to the breast, causing the milk, increasing milk production and secretion in the ducts. So if you're non-lactating, you don't want to make it. So the hypothalamus releases high levels of PIH, Prolactin Inhibitory Hormone, which causes low levels of prolactin. This is non-lactating. Low levels of prolactin, and therefore low levels or no level of sort of milk production. Okay. Now, under lactating, stimulation conditions, this is going to change. And so look what's the stimulus here. We have it in yellow. So the stimulus here is a couple types. One is this baby suckling on this nipple will stimulate basically a nerve going afferent to the hypothalamus, and that's going to create these two effects we're going to describe. But also, it seems so important for the species to survive for some reason, that even the sound of another child crying can stimulate this, because it's sort of just a natural, innate response for women to keep the species going, okay?
Do you have to have the baby for the sound of the baby to make you have milk? Or can like that won't happen to me basically if I hear a baby crying. I'm not going to produce milk.
Enough stimulation and enough noise, because I work in mother-infant, and we've had women in the ward right next to us lactate due to the fact that they're surrounded by women with hormones, and also if you have enough stimulation to the breast, a lot, it will cause that.
So for a non-pregnant,
Or someone who's never had a baby, or.
Really, so excessive stimulation of that can actually cause lactation. So I guess it could. Thanks for actually answering that question. I have no idea. Yes.
Actually, I have a friend who lactates whenever she is around her nephew, baby nephew starts crying and stuff, and just in general.
That's weird because I've never really liked kids, so maybe that's why.
Is it getting hot in here? Sure. What's your question? I'm not even done. Yeah.
I know, right? Well, I was just wondering, we're talking about what PIH and all of this, so in the
So in the lactating, again, just to fill that in then, and then we could go. So for lactating, again, you're going to have one of these stimuli, combination of those stimuli, and the one branch we're doing here is this. It's going to, again, remember inhibiting an inhibitor, it's going to cause a decrease in PIH. So less inhibitory hormone is going to go to the anterior pituitary, which means more prolactin is going to be produced by the anterior pituitary, and therefore it's going to increase milk production and secretion into the ducts to get ready to eject. So milk production, secretion. Not injection, but secretion into the ducts. Okay? So that's sort of what that's trying to describe and what's going over here. So you're going to inhibit the inhibitor. That's another one of those inhibiting the inhibitors. Normally we're inhibiting prolactin. If you turn off the inhibitor, prolactin increases. The target is the breast. It's going to be involved in milk production, secretion. And that's what it shows here. We're, under the stimulation, we're going to decrease PIH, therefore increase prolactin, therefore increase milk secretion.
guess, so my question was like, when you have a child, is that what stimulates it initially? Like, cause you produce milk before your baby's born, so you don't have anything like on your food.
I don't know. I mean, in other words, I just don't know all this. I mean, I think, yeah, I mean, there's progesterone, there's other hormones that are involved in this as well that I just don't know. Again, I'm sorry, I mean, usually too, if you had probably like a female instructor, they do, some people, and I don't mean to make an excuse, but some people do spend a lot more time on this. I really, I'll be honest, I don't, and I don't really know the details. I was sort of looking at some of them, so I don't know. Sorry. I can barely handle this, okay? Okay, let's get that milk out. Okay? we're like down the doors. Okay, let's just try to get this one slide. Okay, before all the breastfeeding questions come at me. Okay? So the last thing is we want to reject it. That's going to involve our friend. Okay? So this again, from one of these stimulations, to get it ejected, we're going to do what? We're going to stimulate the hypothalamus to make and release oxytocin. Oxytocin, again, this time it's the smooth muscles in the breast. It's going to cause contraction, milk ejection. So now, in this case, we're involving both parts of the both lobes of the anterior pituitary. In the anterior lobe, it's like what we've done before, hormone to hormone. We're going to decrease, at least if we just look at these lobes, we're going to increase prolactin to get milk production. Using the posterior pituitary, we're going to release oxytocin to cause ejection. Okay? Again, a positive feedback loop. It's not like we say, okay, you've had enough, baby, and now it's like, you're 2 years old, I'm not going to do it anymore, right? Well, you could say that, but the bottom line is it's a positive feedback loop. So the idea is as long as this stuff's happening, you can keep breastfeeding for, I don't know, there's been weird cases, right? Like some 8-year-old breastfeeding or something like that.
In, we're not underdeveloped nations, but that's actually like not a problem, but they encourage them to breastfeed until like 4 years old because it's a source of food.
Yeah, that makes sense. It is the source of food, right?
So the posterior, hold on. Which is the one that's doing oxytocin again?
Posterior pituitary.
Posterior.
Remember, it's and for the posterior pituitary, for those two hormones, it's a neurohormone. You make the oxytocin in the hypothalamus, but it's released, here's the nerve, it's released by the posterior pituitary into the blood.
Wait, so you're making it in the hypothalamus?
Yes, in the neuron there. But you see the axon, remember the nervous system, it's not, the nerve terminal is actually in the posterior pituitary where it's released and goes to the blood. That's what makes it a neurohormone. It's like a neurotransmitter up to this point, but instead of binding to a postsynaptic cell right here, it's released into the blood, which makes it a hormone. The other ones went like this, where these hormones went through the portal vessels, through the blood, to the anterior pituitary, and that caused release of these hormones, and then everything else we've done. So just remember when we're doing the test, that, I have choices, especially on these, like if you see posterior pituitary, you better not be answering it for any of these things, okay? Posterior pituitary will just be involved in oxytocin or ADH, but I'll primarily talk about oxytocin. So 3 positive feedback loops end the course, okay? All involve female reproduction. I think, I'm definitely aware female are more complex than men, and this is sort of, to come into play here. I don't know a lot. Okay, I'd like to know more, I guess, but I just haven't read that much more about this than this. So, ovulation, childbirth, and lactation, breastfeeding. I hate to end the last sentence on breastfeeding. What else can I say?
Kidney.
Kidney cancer. Let's combine my favorites. No. Any questions? Okay, that is the course. Okay, and I'm going to stay here, let people go, let my rest my voice for people. Again, let's say you're going, the extra questions, again, the answers are there. Be very, again, at the beginning I have you practice, like you were doing an essay kind question, but it's not going to really be essay. But the last 5 or 6 questions I've just put on this year, which comes directly from tests. Okay, some of those might be on this test. Some of those will be on this test, word by word. So you get the idea of the language and how to do the questions. See if there's any problems with that. Again, the answers are there. But I'll also be here to help people with that as well. So any questions about the test?
I have a quick question about the AMH.
Is it constantly being made?
No, only during that period of development.
Just 6-7 weeks?
Yeah, and I don't know exactly how long after that, but just, yeah, this for those few weeks. And then Mullerian ducts go away, and that's it.
All the testosterone.
Yeah, I think, yeah.
The only two posterior pituitary
Oh, you're not.
hormones were oxytocin.
ADH, antidiuretic.
I'm over this. Yeah, I'm not sick.
Yo, cupcakes for
But I
that.
might have
Like a lot of them. Help yourself.